Good afternoon, viewers. This is With God Educational Consult. We are your assistants in science subjects, especially physics and chemistry. The subject for today is physics, and our topic, topic for today is applications of Boyle's law. Applications of Boyle's law. We want to see how Boyle's law is applied in capillary tubes and also in barometer tubes. As we all know, Boyle's law states that the volume is of a gas is inversely proportional to the pressure. So that means the PV is equal to K. PV equal to K. Then we can now arrive that P1 V1 equal to P2 V2. Now let's see how this law is applied in capillary tubes. In a capillary tube, you have a mercury thread that is used to trap a given volume of air, particular volume of air. In this capillary tube now, 50 centimeter length of mercury is used to trap 23 centimeter length of air, length of dry air. When the tube is placed vertical like this with the open end uppermost, you have 20 centimeter length of dry air trapped in the tube. Now, because this tube has a uniform area, then and it has a shape of a cylinder, from the volume of this tube is given as V is equal to AL, area times length. But since area is constant, then even when the position of the tube is changed, the area remains constant. We cannot say the volume is directly proportional to the length. So we can change the volume of the air to, we can change the length of the air to volume. So that means our V1 equal to 23 centimeter cube. Instead of 23 centimeter, we cannot change it to volume 23 centimeter cube. Now, the pressure on air, the P1, the pressure on this dry air, arises from two areas. It arises from the atmospheric pressure. Atmospheric pressure exerts its own pressure on the air. Then the weight of the mercury thread resting on the air also exerts pressure. So two things exert pressure on the air. So the total pressure on air now is equal to H atmospheric pressure plus 15 centimeter Hg. Now, when the same tube is now held horizontally in this position, you can see this position, the tube is held horizontally. Uh, Now, the volume of air decreases or increases. So rather, the volume of air increases because less pressure is exerted on the air. In this position, the mercury thread does not exert any pressure on the air because the mercury weight, with the weight due to mercury is vertical, is resting vertically, so it does not rest on the air. So the only pressure exerted on this air is atmospheric pressure. So the new volume of air, which has a length of 27 centimeter, is now 27 centimeter cube, 27 centimeter cube of air. Now the pressure on the air is only due to atmospheric pressure. So P2 new pressure now is now H centimeter cube. Now applying Boyle's law, which says that P1 V1 is equal to P2 V2. Our P1 is H plus 15, as I've said before. Then our V1, the initial volume, is 23 centimeter cube. Then the new pressure on the air is just H, pressure to atmosphere, and the new volume is now 27 centimeter cube. Now, resolving this mathematically, when you expand, you have 23H plus 234 is equal to 27H. Now, 234 is equal to 27H minus 23H. When you find it mathematically, you arrive at the H is equal to 86.25 centimeter Hg. That is the new atmospheric pressure at that moment. So this Boyle's law can also be applied when solving problems with barometer tubes. When solving problem with barometer tube, as you can see, this barometer tube has a capillary tube also that's inverted in a bowl of mercury. Now, the height of mercury on a day, the height of mercury is 750 millimeter Hg, when the length of the tube is 850 millimeter. So the height of mercury is 760 millimeter Ag. At that time, the atmospheric pressure is 770 millimeter Ag. 770 millimeter Ag. Now, we cannot say the volume of air that is trapped. The volume of air, we cannot find the volume of air since volume is direct proportional to area. The volume of air will not be the whole length of the tube minus the height of mercury column minus the height, that is 750. 850 minus 770, that would be 100. So since we can change the length to volume, since it has a uniform area, it's now 100 millimeter cube. Now the pressure on the air now, the pressure on air. Now atmospheric pressure is that pressure on air, but that pressure is opposed by the weight of this, the downward weight of this mercury height. So which opposes and reduces the pressure on the air. So the pressure on this air is now 770, which has very pressure, minus the pressure due to the height of mercury column. By the time you subtract, it will give you 20 millimeter Hg. Now, another day, the height of mercury has increased to 710, has decreased to 710, sorry, has decreased to 710. Then we cannot find the new volume of air by subtracting. The volume of air will now be total height of the tube minus the height of mercury thread. That was 850 minus 710 millimeter Hg. That will give you 140 centimeter cube. Now, the pressure exerted on the air, as usual, is always pressure due to the atmosphere minus the pressure due to the height of this mercury thread. Height of mercury, that is subtract H minus 710. So by the time you bring it to the equation for Boyle's law, with the P1, V1 is equal to P2, V2. And you cannot say that our P1 is not 20, V1 is 100. Our P2, which is this H minus 710, times 140. By the time you resolve mathematically, you arrive that the atmospheric pressure on this day is now 253 millimeter Ag, 253.5 millimeter Ag. I believe with this video, you understand how to apply Boyle's law in solving problems with barometer tubes and capillary tube. Thank you till we see again. May God keep us.